Okay, this is MATD1534. We're still busy with Unit 9 and the piecewise functions, and now we do combinations of them. So in this example, we have a straight line, and then we have a parabola. So we need to now see, and the boundary point, sort of the problem area, the critical point, is here at -3. Something is happening at -3. So we can once again draw the full graphs, just that we can see what is actually going on here, and then we can then go and see how will we get marks, what must we indicate, etc. So let us just look at what they will look like. So we've got the line 2x plus 7. Oh yeah, let me just say this. When you write the piecewise functions, some of you do not write them in order from left to right. Remember, you have to do that. You must go from left to right with your domain, with your restrictions. So it's from there to there, then from there to there, then from there to there. You can't order this here around as you please. I mean, it must be in order. Minus left of -3 and then to the right of -3, or to the left of -3, then between -3 and 2, and then from 2 onwards. I mean, this is how it's supposed to be. I don't actually understand why people don't do that. Okay, but anyway, this is now the straight line. I will zoom in. Uh, we know it's going to cut there at -3.5, and we know it's going to cut there at 7. The y-axis. All right, but let us just leave it for the moment and just put the other function in also, and then we just see what it looks like. I'll move it up now just that we can see. Just want to get the correct function there. So this is x squared plus 4x and then plus 3. Okay, so this is what the parabola will look like. So let's just open it up a little bit that we can just see. Okay, so this is what the original two graphs will look like. Now, this is not a function, of course, because the graphs are on top of one another. Then it's not a function. So now I must see um, what do they want me to draw? Okay, so I need to draw the line to the left of -3. So -3 is at this x-intercept, it looks like, of the parabola. So from there, I have to draw the straight line. So -3, I'm going to find the value there for -3, and I'm just going to draw the straight line down there. Okay. And then I have to, when it's greater than, let me just see, when it's greater and equal to -3, I must then draw this parabola. So you see this x-intercept is going to come into play, the y-intercept is going to come into play, and the turning point is going to come into play. So this is going to be large, um, uh, in marks. And this piece here is going to contain a lot of the marks, because you will have to show the x-intercept, you will have to show the turning point, you will have to show the other x-intercept, and you will have to show the y-intercept. For this straight line, you're just going to work out -3, the value there. Well, -3 gives me 1. So at -3, I wonder if we zoom in a little bit. I think we can see that at -3 it's going to be 1. All right. So there's going to be a hole there. I'm going to show the -3,5 here. So I'm going to have the -3 go through -3,5 all the way down. So go here to the inclusive point. Show it, show the turning point, show the other x-intercept, and we're going to be done. Okay, so let's keep it there and start here now. So I think the best way for us is to just tackle the two functions and say, okay, let us see if I have 2x plus 7, and I work out where that is 0. And again, you do not have to show lots of calculations now. As long as you just, show it's going to be at -7/2. So that is my x-intercept for this graph, which I will just show here. And my y-intercept for this graph is just going to be y is 7. So I know now because we looked at the graphs on the software that that is not going to come into play. But when I start the sum, I'm not 100% sure yet, so I need to do all that. So when I start now with x squared plus 4x plus 3, okay, then of course I need to do the three things that we said so often. What is the turning point? What is the x-intercept? What is the y-intercept? So for the turning point, you can use um, those coordinate one if you want to, or you can do minus b over 2 and substitute, or you can do completion of the square. It's all your choice now. So we can do minus b over 2a, so it's minus 4 over 2. And then we could do 4ac, so 4. Let me just make some more space there for us. I'm just afraid we're not going to get it in there. So 4 times a times c minus b squared, which is then 4 squared, over 4 times a, which is 4. Okay, and then I can substitute that, and I mean, I've already substituted. I could just calculate that. So this is minus 2 here, I think. Just watch me. And then let's just go to the fraction mode quickly there. And then that will be 4 times 1 times 3. I entered it exactly as it is there, so that the calculator work out for me what I want. It looks like minus 1. So I've got my turning point. My y-intercept I know is going to be 3. So y-intercept is just going to be y is 3. And then I need to do the x-intercept. So my x-intercepts. Okay, now if it has factors, I go for that. But I'm not going to waste time. And if it doesn't have factors, I go for the formula. Or I can do completion of the square and do the plus minus root like we've done. So we've done the basics now, you see. Now we need to use. Now we need to apply the basics. So we're applying what we've learned. Okay, that is minus 3. There comes the minus 3, and I will immediately tell myself in a test, hey, I must be careful now there, because that is where everything is changing now. So I immediately see that. Okay, so then I go to my axes. I'm going to put that now up for myself. Okay, let's draw it somewhere here. All right, let me use black for that. Okay, and remember, it's not according to scale, so I can just enter a point. I'll show you now what I mean. As long as it's still logical, it must still be logical. So in other words, 3 must be higher than 2 and things like that. That's what I mean by logical. Don't enter now things in that is just not logical at all. Okay, I think that'll be fine for now. All right, so now I'm going to indicate all the important points. So here at minus 3, I've got my, okay, let's say 1, 2, 3. Yes, so this is minus 3, more or less. So here at minus 3, I think I must move it a little bit to the left there. Okay, wait. Let me just, I'm going to delete my line there. Okay, I just want to make this also just a bit, yeah, thinner. Okay, let us just for now write the minus 3 over there. Okay, and now I'm going to look what happens at minus 3 here. This is important. So now I already know if I substitute minus 3 in here, I'm going to get 0 there. I already know that now because of this here. And then if I substitute minus 3 in here, I get a 1 there. So this is going to give me 1 there. Okay, so now I see, okay, so my straight line is going to be minus 3, 1. Minus 3, 1. And that must be a hole. Okay. And I know, I think it wasn't a good choice to put the minus 3 there. Let me just get the minus 3.5 first, that minus 3.5. So let's say it's about here. So I'm just going to write the minus 3.5 there. Okay, I'll later put in the minus 3 because I want to draw the parabola, and then I will put in the minus 3 that it's not in my way. Okay, so now I need to draw my straight line through there because I know it's the straight line going through there now. Okay, so I'm just going to do that. Okay, so I've done that part with saying less than. Okay. Okay, this graph is going to go on there. And I've got 2 points on it. I've got the minus 3.1 on it, and I've got the minus 3.5 on it. So now, if I look at my parabola, I know the turning point I worked out to be minus 2, minus 1. So minus 2, and it's going to go through 3 and minus 1. Okay, so minus 1, minus 2. Okay, so my minus 2, minus 1. Okay, so here is the turning point of the parabola. Minus 2, minus 1. And this parabola is going to go through 3. Now that's 1. So 1, 2, 3. That's about 3. It's going to go through 3 there. So a nice curve. Give it a nice turning point, please. Okay. And a nice curve, which is not so easy on this, but you get the idea. It's going to go through there. Okay, let me just try to fix that a little bit. This little pens on this is not so easy, but okay. I think you see the idea. That's what it's all about. We can still teach with this. Okay, all right. So that's my parabola, and I'm showing that that is minus 1. I'm showing that that is minus 3. I'm showing my y-intercept. Just check that that is inclusive there, which I have shown actually. That's a hole. It's going through there on the x-axis. I think I've got everything. And then I'm going to get my 8 marks or so, because this is about 8 marks or so.